Hello and welcome. Let's take a case of solving a linear programming problem by graphical method. And the case is maximize z equals to 15x1 plus 10x2 subject to the constraints 4x1 plus 6x2 less than or equal to 360, 3x1 plus 0x2 less than or equal to 180, and 0x1 plus 5x2 less than or equal to 200. And x1 and x2 both are greater than or equal to 0, that means non-negative. Okay, now what? To draw a proper graph, first we are going to segregate these inequalities into two parts, equality as well as inequality. Because all the three have mixed signs, less than or equal to, less than or equal to, less than or equal to. Inequality and equality. First equality, 4x1 plus 6x2 equals to 360. If it is 4x1 plus 6x2 equals to 360, then what can be the possible values of x and y respectively for relevant, or rather x1 and x2 respectively for relevant values of x2 and x1. If in this equation x1 takes value 0, then what happens? It becomes 6x2 equals to 360. That means x2 will be 60 if x1 takes value 0. Similarly, if x2 in this equation takes value 0, what is going to happen? 4x1 equals to 360. That means x1 equals to 90. So we can say that if x2 takes value 0, x1 will be 90. We have 2 points, so we can easily draw a straight line for this equation. So we are not going to take any more value. Now inequality part. 4x1 plus 6x2 less than 360. Okay. Now again, if x1 takes value 0, what is going to happen? 6x2 less than 360, that means x2 will be less than 60. And if x2 takes value 0, it will be 4x1 less than 360, that means x1 less than 90. Now in this case, first equality, 3x1 equals to 180. That means x1 equals to 60. The meaning of this is, for any value of x2, x1 remains constant at 60. x2 takes any value, then x1 remains 60. Okay. Now what? It is not necessary to prepare this kind of box in case there is only one equation in the constraint. Only one variable in the constraint, I am very sorry. But let's simplify this x1, x2 for whatever value of x2, x1 will remain 60. Now inequality part, 3x1 less than 180, so x1 less than 60. In this case also, let's first take equality, 5x2 equals to 200, that means x2 equals to 40. So for whatever value of x1, x2 is going to remain constant, 40. The important thing is to learn how to draw the straight line of this kind of constraint where there is only one variable. Okay, inequality part, 5x2 less than 200, so x2 less than 40. So now we have all these things. And now let's draw a diagram on the graph paper. So please take a graph paper, and since all the numbers are in multiple of 10, we are going to take scale of 10. On x-axis it will be 1 centimeter equals to either 5 or 10. If you want to draw a graph of say larger size, you can take 1 centimeter equals to 5 points on both the axes, or you can take 1 centimeter equals to 10. In that case, the image of the graph will be quite smaller. Okay, just to have the sufficient space to draw a sketch of graph, I am going to draw only a sketch of graph, because on this board I cannot draw a graph with exact measurements and exact scaling. So I am just going to draw a sketch of graph, but on the basis of that you will be able to understand everything. I am just going to repeat this one at here. Okay. And we are well aware that both are non-negative. This is x2 axis as well as this is x1 axis. On x1 the lowest value is 10 and highest value is 90. So we need either 9 centimeters or 18 centimeters. Now what scale you are going to take is upon you, but please use graph paper. You please don't draw this kind of sketch. Every time, whenever you go for practice of graphical method, use graph sheet. On x2 axis, the lowest value is 10 and the highest value is 60. Okay. Now, this one, in this case, x1 is 90 when x2 takes value 0, and x2 is 60 when x1 takes value 0. x2 60 and x1 0. On this vertical axis x2, x1 is always 0 on this axis, and on this axis x1, x2 is always 0. So whenever it is x1 equals to 0, that means this line. x1 0 and x2 60, it is here. At this point x1 is 0 and x2 is 60. Similarly, x2 is 0 and x1 is 90. On this x1 axis, at every point x2 is 0. So x2 is 0 and x1 is 90. That can be here. Okay, now we have 2 points lying on same straight line, and to draw a line 2 points are sufficient. You just need, or rather we just need to draw a a line passing through both of these points. On this kind of board, it is not possible for me to draw a straight line, and I am going to draw a sketch, you are well aware, but you please use the full length ruler of 12 inches at least to draw the line and be as much accurate as possible. This is just a sketch. So this is the line of the equation 4x1 plus 6x2 equals to 360. Now what about this inequality part? The first is x2 less than 60. Where is x2 equals to 60? Here. And where are the values of x2 less than 60? This side. So draw a small arrow indicating that side. That means x2 takes value 60 or less. But because of the non-negativity constraint, x2 is not going to take any value less than 0. So we are not going to draw the remaining part of the graph paper. Now, similarly, x1 less than 90. x1 is exact 90 here, and less than 90 means all these values, and because of non-negativity constraint, x1 is not going to take any value less than 0, 90 or less. This is the importance of segregating the inequality to two parts, equality as well as inequality, so then we can correctly determine the side of the inequality, whether it is going on graph paper below the line or above the line. 60 or less, 90 or less. Is it? Okay, now in this case, for any value of x2, x1 is going to take value 60. That means x1 remains 60 for any possible value of x2. x1 60 is here. Now what? We have only one point, and to draw a line we must have at least 2 points. x2 10 and 60, you can think in this way also, and x2 60, it is also 60, almost here. You can determine this point accurately on graph paper. But the another thing is, if the equation has only one variable, then take its value on the axis of that variable and draw a line passing from that point parallel to the other variable. Here it is x1 equals to 60, x1 60, the line will pass from x1 equals to 60 parallel to x2. If you understand this thing, you need not to prepare this kind of box and assume this kind of values of another variable. Approximately it will be of this kind. This is the line of x1 equals to 60. Okay, now what? x1 equals to 60, okay. What about inequality part? x1 less than 60. x1 less than 60. Yes, less than 60 means either 50, 40, 30, 20, 10 or say up to 0. But it cannot go, rather take value less than 0 because of non-negativity constraint. Similarly, in this case, x2 is 40. Okay, x2 is 40. No x1, so the line will go parallel to x1. x2 is equal to 40. And again the inequality is x2 less than 40. Less than 40. Yes, sorry. 40 or less. Okay, now we know that this is x x2 equals to 0 and x1 equals to so and so. So this is x2 0 or more. This is x1 0 or more because x1 is 0 on this line and greater values on this side. Okay, this is x1 60 or less. 60 means line and less means inner side. You need not to draw the shaded region outside the common region, but to understand the common region accurately, I am drawing this kind of lines. Yes, okay. Now this is 60 or less, 90 or less. So this line is going to, rather this inequality is going to below the line. We are interested in the common region of all the constraints, and this is the common region. Shade it properly, and more precisely, actually we are interested in the corner points, vertices of the common region. Yes, vertices or corner points. Which are the corner points? 1, 2, 3, 4 and 5. Okay. This is say O. 0, 0. x1 and x2 both take value 0 here. Say this is A. At A, x1 is 0, x2 is 40. This is B. At B, x1 is 30 and x2 is 40. If you have drawn your graph properly, it will be exactly 30 and 40. This is the another point of common region, feasible region, convex polygonal region C, and at point C the coordinates are 60 and 20. x1 is 60, x2 is 20. And this is the last, say D. At D, x2 is 0 and x1 is 60. These are the 5 vertices or corner points of the feasible region. According to the fundamental law, fundamental principle of linear programming, the optimal solution of a linear programming lies at any one or more of the vertices or corner points of the feasible region, where feasible region means common region of all constraints, that is determined on the basis of the lines as well as shaded region of all the constraints. Line indicates or represents the equality part of the constraint, and the shaded region represents the inequality part of the constraint. And the common region is shown by the shading. See, all these shading have no importance, only this part. So you can show the shading on this part only, in the feasible region only. Now, how to determine at which particular corner point the optimal solution is lying? For that purpose, we have to substitute the values of x1 as well as x2 at the coordinates of all the corner points. What is the objective function? 15x1 plus 10x2. And what is the objective? Maximization. Let's check. We have to check it by writing only. So we are going to write that part. Yes, corner point or vertex, coordinates at the vertex z equals to 15x1 plus 10x2. Okay, at O both are 0 and 0, so the objective function is going to take value 0. Okay, let's take me the last benchers into consideration. It will be 15 into 0 plus 10 into 0, so 0 plus 0, 0. At A, the coordinates are 0 and 40. So it will be 15 into 0 plus 10 into 40, so 0 plus 400 equals to 400. At B, they are 30 and 40. It will be 15 into 30 plus 10 into 40. Okay. 15 into 30, 450. Plus 10 into 40, 400. So total value 850. At C, they are 60 and 20. 15 into 60 plus 10 into 20. 15 into 60 means 900. Plus 10 into 20 means 200. It takes value 1100 or 1100. And the last corner point or vertex is D, that is 60 and 0. 15 into 60 plus 10 into 0. So it will be 900 plus 0 equals to 900. What is the objective? The objective is to maximize the value of objective function, and the objective function takes its maximum possible value at vertex or corner point C, where x1 is 60 and x2 is 20. So the optimal solution of this LPP x1 60, x2 20 and maximum z, because the objective is maximization, 1100. Yes. Now I suggest you people to solve this problem by simplex method. We have already a separate playlist on simplex method as well as big M method, and since this case has all the less than or equal to, all the constraints with less than or equal to sign, we can solve this by simplex method. So I suggest you to solve this particular problem by simplex method and observe what exactly happens. You will find at the end of each and every simplex table